welcome to another SmartQA Musings, which is a gentle flurry of interesting thoughts. And today's, we are going to explore something counterintuitive. The testing paradoxes, where even adding more tests or using tools and automation to improve efficiency, it sometimes backfires. So we'll unpack these four paradoxes that explain why and when, and end with what we can actually do about it. This particular musing was inspired by a recent article that I read in the Hindu, which had nothing to do with software testing. It was about decarbonizing the grid. It was about energy efficiency. It was an article on solar power, and the article was titled "The Case for Energy Efficiency." And interestingly, the article had an interesting paradox, which set me on thinking, and that's how the idea for this musings came about. So what's this article about? It actually said there is an interesting paradox in India's renewable energy scheme. India is probably one of the largest adopters of solar energy, and we've been adding a lot of solar energy plants in the country. The renewable capacity has actually doubled to about 25% of the total to 50%. But then the interesting part that the article talked about is it's still dirty. What do you mean by dirty? It means that whenever we generate power, we do emit carbon dioxide. And there is a measure called the grid emission factor, which talks about how much of carbon dioxide we generate for every megawatt hour of power that we produce. If you look on the right side, you find that metric called grid emission factor has been increasing despite using renewables from 0.073 to 0.727 tons of CO2 per megawatt hour. What's going wrong? We thought that if you use renewable energy, the grid should be cleaner. The capacity has improved, grown apparently, but emissions also have increased. The system looked better by numbers, but it really performs worse. And that's an interesting paradox. And that's what set me thinking, and because there's the same paradox that we have in software testing. In this case, the paradox is more renewables should be lesser, cleaner energy, but it's actually becoming dirtier grid. So the power today that we have is still unclean. We have the energy grid with 50% renewable capacity, which has received massive investment, got modern infrastructure, but still not clean enough. And the same thing is there in software testing. We might have test suite with a lot of test cases, seemingly indicating some kind of high coverage. We have invested in terms of automation quite a bit. We have put them into a pipeline like CI/CDs. Still, we seem to find interesting issues that linger around and happen in production. Not that we are looking for zero defects, but we don't want those kinds of defects that require more money and time and effort and rework. So the question is, what can we do? Despite having more test cases, more coverage, more automation, does not yet translate to less bugs. So, the first paradox that we started off is the capacity illusion. There are three more interesting paradoxes, and we'll connect all these three in a very interesting, cogent fashion. The first one is called capacity illusion, where more is not necessarily great. The second is called the activity trap, which means being busy and doing more activities does not mean great outcomes. Third, the efficiency trap, where we speeden up things, maybe in our case, maybe automation, AI, and so on and so forth, tools. But speed results in more volume, and they don't necessarily turn out always effective. And four, we end up skilling ourselves, doing some more what is called as more training, so to speak, to do a job better. And we'll take that example from a sports analogy. But we find that despite the fact that you can enhance the training, the act of doing what we do, it's still counterproductive, because a training without a recovery, in the case of testing, it is less maintenance, and no maintenance of test assets is counterproductive. So we are going to look at these 4 paradoxes in terms of more, in terms of capacity, more in terms of activities, fast in terms of speed, and finally more in terms of training. So all of them have one common thread: more. Right? And maybe we have to figure out that maybe more is not the answer. It's probably less. Let's see. Let's talk about the first paradox, the capacity illusion. It's like saying, look, it's like being able to have more capacity in the context of testing, maybe more better coverage, does not translate into protection. It's like saying more insurance coverage is not protection, crudely put, right? What do we mean by that? That's what we started off as an example. We said that there is 100 megawatt of capacity that we've added, but actually 100 megawatt of solar capacity only results in 20 megawatt of actual generation. What do you mean? Its efficiency is about 20%. Solar power efficiency, generation efficiency is 20%. Remember, it was much lower before. So the first key sight is to understand that there is a difference between capacity and realization. Solar seems to look great on paper, like this. If you look at comparative other statistics of other modes of power generation, solar gives you a 20% utilization. A windmill gives you 25% utilization in terms of generation. Coal, which is what we use, majority of it in India, for 100 megawatt of coal that we use, we get 75 megawatt of power, which is 75% of the energy is converted. Which seems great, isn't it? But the coal is the dirtiest energy. So, capacity is not equal to generation. So, adding more does not result in meaningful outcomes. Same. The second problem with solar from the energy standpoint is solar power is produced when there is sun. And therefore, the grid floods, the electricity floods the grid at noon, during the daytime, more often when it's really shining. But really the demand peaks at later in the evening, maybe 7 p.m. and upwards. So what happens? The solar doesn't make sense in the night, so we have to burn coal. And therefore coal fills the gap. So what are we talking about? At the peak times, that capacity which we added does not help. So what does it mean? How do we start correlating to our work of testing? Test when it matters, not where it is easy. That could be one takeaway from this peak demand analogy. Now what is capacity illusion in the context of testing? We'll take a look at it right now. I put crudely in terms of coverage. You can call it whatever you want. You can say code coverage, test coverage, whatever you think is more appropriate to say numerically. I think I'm doing a great job. So maybe 85%. Maybe my 100% of tests are passed. My bill status is okay. I've got some great dashboards today. Everything looks great. But reality doesn't exactly mirror this wonderful capacity that we have. So, what's probably happening? What is the paradox? It's probably we have got a lot of tests which are at a lower level of testing data, interface, functionality, and so on and so forth. Interestingly, when I consult, I see this very regularly in the case of the methodology, which is of HighBest, where we look at defects and test cases in terms of levels. The L1 to L4 levels represent the left side. Early stage tests could be testing individual pieces, components, basic features. But what is probably needed is more like end-to-end attributes, certain interesting critical paths, and so on. maybe they aren't there. So we have a lots of tests, which is like capacity, lots of it, but in the wrong place. And in many companies that I've consulted and I've analyzed the test cases, analyzed the defects by distributing them into levels, I find that the left is more predominant. That means we've got lots of tests and therefore sometimes lots of bugs in the early stages of L1 to L4 quality. But higher levels of quality, which relate to end-to-end, customer-oriented, deployment-oriented, attribute-oriented, there isn't a whole lot. And therefore, when you get an issue, it takes a lot more effort and time to fix. So, that's the illusion of capacity, right? Just because you have more doesn't mean better. Because in the case of solar, it is high capacity of solar, but wrong timing because it doesn't work during the night. Much like in testing, we seem to have covered everything, but probably in the wrong area. And that's the challenge that we can keep in mind and understand this paradox and constantly adjust it. So this is paradox number 1. High coverage doesn't protect you when it matters unless you're sure that you're in the right area. So that simple metric by itself, you have to take it with a pinch of salt. The second paradox is the trap of activity. I'm busy. I'm doing a lot of work. The question is, are we spending our effort or time or money at the right places? Are we just busy? Let's take a look from a completely different situation. It is not about energy now. I'm going to shift to healthcare. And this is a real fact. If you look at the US healthcare spending, the data from 2021, it says that US spends probably one of the highest in terms of healthcare, about 4.3 trillion, and most per capita, as you see on the left side. Most per capita. It's here, the big red line. That's the spend. But, interestingly, the outcomes are not as high. So you spend this big red line on the left and the big red line on the bottom, on the right side. Expectancy is lower. Why? What's wrong? More spending should result in better outcomes, but it's exactly the opposite, and that's the paradox. And we're going to relate it to the notion of doing more but not getting outcomes. So let's take a hypothetical case of a misallocated team, let's say in a sprint. Just an hypothetical example, probably pulled in a little too deeply, a bit of hyperbole maybe. So let's say how the day looks like. This Monday, they spend 3 hours, they do some unit test, something like a CRUD screen. Maybe the next day they do some kind of a E2E end-to-end test, maybe fix some of them. Maybe they do some code review on the third day, they check out some stuff, maybe some login page or some page for speed, but there isn't a whole lot of time to investigate. And then come Friday, maybe have to run a regression. So we are kind of busy, right? Monday, Tuesday, Wednesday, Thursday, and Friday, they're busy. The team isn't lazy, they're very busy. But they're busy probably with the wrong things. And that's the activity trap that we're talking about. It's not that they don't care. It's just that maybe stuff like interesting payment integration, which could cost us millions of dollars of loss, maybe we don't have enough test cases or we didn't focus on it. Maybe we need to look at some meaningful shopping cart for performance test. Maybe we're not doing it as much. These are just hypothetical examples, right? So what we're trying to really ask is, are we spending the capacity? Are we doing things in the right time, in the right place? Is the capacity meaningfully consumed? And that's why just doing more activities is a problem, right? Which means if I had a lot more trivial unit tests, or every time I do basic regression in full, or probably redundant tests or over mock, I'm just busy. A lot of activities. But maybe achieve less. Maybe some of those deeper tests, some of those longer tests some of those critical paths and tests may not be enough. So you see, doing lots of trivial and missing the key ones, which results in more activities, not enough outcomes. Not because I'm lazy, it is just because I haven't probably figured it out correctly, figured out the right set of priorities, so to speak. We therefore have an imbalance. We're busy, but ineffective. Now it's interesting. In the current world, now we have AI. Is it a solution or an amplifier? Every time I see an interesting, feature set or a brochure of some AI tool, it says, oh, you can generate 1,000 tests in 1 minute. You can execute so much. What happens? Is it good or bad? Like, it says everything is automatic. It certainly promises efficiency. It probably ends up writing hundreds of tests in minutes or seconds. It optimizes what it can measure, quantity. Is that what it is? Is that what we want? So does it necessarily mean more amount of these kinds of early stage simple test cases? Does it mean any better? It just accelerates the imbalance. So be cautious when you look at AI, because some of these tools exactly do that. And when I look at some of those test cases that the tools generate, they generate fairly simplistic tests, which really don't produce a lot of value, but there is seemingly a lot more volume. So we just have to be careful with AI in terms of it promises efficiency but amplifies some of these habits which are not good. So we have to be careful. AI is an accelerant. It magnifies your intent. If you have a good strategy, certainly it helps you to test or assure smartly. If you have a weak strategy, then it increases the noise exponentially, because AI can't really tell you what is important to test, what is critical versus trivial, what to prioritize. It is certainly intelligent and smart, but it's also an accelerant. What does it mean? It can warm your house or it can burn it down. So be careful with it. Just because it says I can do more and faster doesn't necessarily translate to value. Don't get into the activity trap of saying, oh, I ran, I executed, I designed, I validated with a few hundreds and thousands of tests. It doesn't really value. Volume doesn't cut. Again, the concept of more, right? So without a clarity of purpose, you will probably drown in the tests. Third one, the illusion of speed. Oh, I didn't really mean to say the, but I guess it's a typo there. We normally like to always focus on efficiency because we're engineering folks. We always look at faster so that we can do more. Especially in testing, we use tools more often in that context, right? But they're not necessarily effective. So having seen those two paradoxes, this is probably a little more dangerous because it gives the illusion of speed. Now I'm going to go back to an interesting economic aspect. So we talked about solar energy and saw an interesting paradox of capacity. We saw the healthcare spending and we saw the trap of activity. And now we look at an interesting paradox which was published by an economist, an English economist, William Stanley Jevons. And it was written in his book called The Coal Question in 1965. What Jevons observed was England's consumption of coal soared. It increased significantly after James Watt introduced the Watt steam engine, which greatly improved the efficiency of the coal-fired steam engine invented by Thomas Newcomen. People thought if he improved the efficiency of the steam engine, our coal consumption would come down. But in reality, it went up. I'm sure you can relate this to a variety of things that we do today. Like one that I am very fond of is about lighting. Once upon a time we had incandescent lamps, then fluorescent lamps. That's what we normally use at home. Now, of course, we've got LED lamps which claim higher efficiencies. So you probably get a an 8-watt LED lamp which can function like a 100-watt incandescent lamp. But what happens? Did we exactly replace a 100-watt incandescent lamp with one, let's say 8-watt LED? No, we ended up adding more. So interestingly, whenever efficiency increases, cost drops, people buy more usage happens, and that is what Jivan's paradox is. So it's a counterintuitive phenomenon where when you make improvements in anything, in this case it was energy efficiency, and that's what he studied, that whenever you improve something and make it more efficient, we consume more. And therefore we end up using more. It's not about less. And that's the truth today for anything. Because engineering business is all about enabling scale. And to enable scale, we always reduce costs. When we reduce costs, we increase consumption. And that's the truth. So what's the connection? That's the rebound that we have in testing. Maybe the first time I had tests which could take 2 hours. Then we said, oh, we can do parallel execution. Maybe finish in 15 minutes. Oh, you finished in 15 minutes, right? So what we used to take 2 hours now 15 minutes. We seem to have more free time. So let's add more tests. And after about a few months, what used to take 2 hours, which reduced to 15 minutes, which we added more, we're back to 2 hours. Why? Because we speeded it up. And because we speeded it up, we said, hey, we must fill it. And we added more tests. Same total time. So we optimize ourselves into inefficiency. And we mistake this motion sometimes for progress. So it's important to keep in mind the Jivan's paradox, which was stated in 1860. And we see that in technology today in variety of different stuff, right? So if you have an automobile which comes down in cost, more people buy it. So what happens when more people buy it? We actually go slower on the road, which I think is very prevalent in a lot of cities. And of course, I live in Bangalore, the capital of jams. And therefore, this particular paradox is called the efficiency trap. Like we made mocking easier, we made pipelines easier, so we have over mock tests, more deploys. We are automating everything because it's kind of free. Infrastructure is cheap, so we add more tests to fill the capacity. Just because things can be done easy today, we end up doing more and therefore foster higher consumption. So remember, efficiency does not translate directly always into effectiveness. The faster we test, the more we consume. So this is Jivan's paradox in software. And I think it's applicable in a variety of different situations. And let's go back to AI. AI seems to be the ultimate efficiency tool. What humans do in a few minutes, it takes probably a few seconds. Maybe we get multi-x times gain. Maybe let's say 30x. So what does Jivan's paradox predict? It says if you get 30x gains, that is 30x efficiency, you would naturally fill it with 30x more tests. So are you really being more efficient is a question, right? So that's why we are back to the same number. We again fall into the trap of more. Because we're able to do fast, we're able to get more, right? And this paradox feeds in with the first one that we talked about. And it encourages the second one of activity. And therefore, this 1, 2, and 3 are a brilliant cycle. They feed each other beautifully, right? Something that I notice very commonly in a lot of consulting that I do with organizations, and the methodology that we profess as part of SmartQA is what I use to actually break this cycle. So, we have 3 paradoxes we talked about, right? Capacity, that doesn't really protect us. Or coverage is what we said. Resources are misallocated. And efficiency that increases consumption instead of reduction. Now let's come to the last paradox, and let's take this from an analogy from sports. I call this paradox as resilience paradox. If you do any sport, common ones, I do running and cycling, I am sure there are very many sports. What do you normally do? You build strength. Right? So if you want to run, if you want to cycle, if you want to swim, what do you normally do? Any sport, or if you want to play football or badminton, you build strength. You go to the gym, you lift weights so that your muscle is strong. Question is it true that if you had more training, build more strength, does it actually translate to strong? Interestingly, it's not always true. Let's take a look at it. This picture, which is taken up from a physio site, which is listed at the bottom, simply says that you can increase the training load, and I put it in terms of 3 zones, where you can see the x-axis is load of training. So you do more training load, so that you become more strong. And then the y-axis is performance, outcome. So the deal is pretty simple. Athletes who train more get fewer injuries, which I think is pretty true, because you can't go into a sport and do full blast if your hand is strong, because you will get injured, and injury is the most terrible thing for a sportsman. But you see this curve there. In the zone 1, we train less and we recover more. That means we spend less time training and more time resting. The second one, we train, but it's equally important to rest and recover. That's optimal recovery. And as we go further down, we start saying, oh my gosh, I got to train more and more and more. So I'm going to lift more, I'm going to spend longer time in the gym or stuff like that. So I start training more. But it comes at the cost of recovery. Because I'm training more, I have only a finite amount of time, I am skipping the recovery. Right? I may sleep less, I may do whatever recovery exercises less, because I'm spending more time there. And therefore, once you start finding that you're doing more training but you're recovering less, the performance drops. And so, the optimal zone is zone number 2. And that's what I'm going to relate to when it comes to testing. The zone 1 is under testing. Maybe you have got coverage, you got fragile code base, you got not so great test cases, you don't want to change too much. So it's like, it's not strong. Zone 3, you got lots of tests. Maybe you've been adding over many versions, many cycles. But you don't do much of maintenance, which is equivalent to recovery. So you see the tests are still fragile. They're not as good. So what do we need to be? We need to have high tests, good number, meaningful coverage, right places, but constantly refactor them. Which means there is maintenance, and it could be test cases, it could be automation scripts, it could be test data, everything, right? So a combination of a good amount of testing and a good amount of maintenance is what makes it resilient. So the question to ask is, are we in the right zone? Right? Because the zone 3 looks very interesting. Oh, I've got a lot of tests. It looks very strong, but breaks very easily. Especially, I'm sure, if you would appreciate it, if you automate a lot of it, it becomes fragile, right? I experimented with this idea with a customer many years ago. I called it as potency in immunity. I said that your test cases are potent if they can have an ability to find an issue. A test case is immune when it doesn't find an issue. Either because of the fact that area is very strong and you don't have to unnecessarily train them, or maybe it's not applicable anymore. Interestingly, when I did that experiment, I worked with the customer to understand what is the yield of test case. So I found for every few test cases that I ran, what could be the potential yield of issues. As the yield dropped, I understood that area has become strong. So I don't have to waste my time. So I started working on improving the yield by looking for certain kinds of more interesting defects with a fewer set of test cases, and the yield increased dramatically. In that particular case, it was about 10x, statistically large number, and that's because the version of the product was, I think, version 8. So the product has been around for a decade plus. So it's constantly important to refactor. So all I did was to, refactor some of those test cases, add some brand new ones which were meaningful in this current context, and continued to make it strong. So I called it as immunity in potency then. So it's not about over-testing, but it's about under-recovery. Unmaintained tests, constantly figuring out, adjusting, is terribly important. It's not about just the act of designing test cases or, in whatever form you want to keep it, but it's about refactoring, which means adjusting, deleting, curating, idea of recovery. So the maintenance is really the testing's nutrition. And that's an effort. The question is, do we? Now we see this problem in infrastructure, roads, right? Where we find that you keep on adding newer roads, you keep on doing some white topping for existing roads, but you ignore. You make new roads, you put a brand new road, you don't maintain it well, and that's where a lot of roads go into disarray. So the public infrastructure of mobility in urban cities here, the problem is we don't maintain because maintenance is expensive. They're easy adding new stuff. The problem repeats in a variety of different situations. So recovery is as important as strength building. Right? So if you use AI and you can generate infinitely more and stuff like that. But what you have to be careful is AI cannot do the other ones. So you have to work with AI to prune, adjust, improve. So be careful when you use AI because it is going to be able to add more to your list. So you have to work with it so that you can curate along with it a little more wisely. Right? And there is an interesting problem that comes out with intelligent systems now. So use AI from a curation perspective to detect maybe potential redundant tests, to flag those tests that, don't fail, to analyze constantly the cost of maintenance and stuff. So that is a very intelligent use of AI where we can co-create with AI to curate what I have. So as we come to the end, let's summarize a little bit and see where we are going. Irrespective of whether it's a power grid or test suits, systems decay the same way. We measure wrong, we invest in the wrong place, we become more efficient at the wrong work, and we consume, we forget the upkeep. So you can list it down as measuring wrong, misallocating resources, optimizing too much, consuming more, degrading assets, and the whole thing viciously repeats and cycles in a downward spiral. So what we need is to break this downward spiral. So what can we do as a final leg of this musings? Let's break by looking at it from 5 points. Like, change your thinking in terms of what is called as first fuel thinking, where we focus on the demand side. First fuel came from the energy sector. You supply, you have demand. So you supply by adding more energy, more solar power, more wind power, more hydroelectric dams, more coal. Why? Because there is demand. So what is first fuel thinking? Don't look at it from supply side. Look at it from demand side. Manage consumption first, then worry about generation. So what are we trying to do? Prevention versus detection. Right? The idea of strategic testing, we'll talk about it. Focusing on the right areas. The notion of recovery as an investment to constantly ensure that tests are good. The strategy of where we adopt AI meaningfully. And finally, what do we measure? Activities or outcomes? So let's take a and look at all these 5 as to how we can help is to break the vicious cycle. So the first field thinking is about saying, look, focus on the demand. Prevent, focus on more prevention rather than detection. So don't invest all the energies primarily in finding more. Do something that you can prevent or preempt. That's first field thinking. Demand side, not the supply side. The strategic testing, test what breaks, not what's easy. So look at more deeper issues. Look at more longer flows. I'm sure we all do that. All we're trying to say is focus on those that are probably more ubiquitous, deeper, longer, stuff like those. Not necessarily what is easily visible, not what's easy, which we call it in terms of level 1, 2, 3, 4, in terms of harvest. On the third and the fourth, recovery as an investment. So constantly refactor test cases. Delete stuff which you think is useless. So we all get worried about deleting some of the test assets, right? But removal is as important as addition. Right? But so invest in recovery. And as a strategy, use AI not to blindly generate an increase. Use it to curate, not to flood. And lastly, shift the way you measure. It's not about how much of activity has been done. Has the numbers increased? They're good. I'm not saying we should not, but focus on outcomes. Maybe measure confidence, maybe measure escapes, maybe measure time to detect an issue, can be reducing, stuff like those, which are a little more outcome oriented, not necessarily only activity oriented. And therefore, when we think on these 5 lines, what we see is, the final insight is, it's not about more. It is about less, but better. So measure right, allocate right, recover right, and stay resilient. So paradoxes really remind us that more is seductive, but it is shallow. The smarter path is about depth. It's about clarity. It's about balance. Be it in testing, or in energy, or in healthcare, or in sport, better is better. And that's what our primary focus when we talk about SmartQA and the methodology of HighBest, which is really about how can I do less yet accomplish more. It's about probing smarter, seeing deeper, so that we can assure better. Thank you so much and have a great day.